Hi, wishing you all. I'm Dr. J. Glory, Institute of Aeronautical Engineering. So today we shall discuss about the interplanar spacing and then lattice constant. So here in the interplanar spacing, so it is also called as interspatial distance. Interspatial distance or interplanar distance also. Okay, so in interplanar spacing, we are considering a plane ABC intercepting all three axes at distance OA, OP, OC at A by H, A by K, B by K and C by L. Okay, here we are considering a plane ABC, and this ABC plane intercepting all three crystallographic axes at distance OA, OB, OC at the distance A by H, B by K and C by L respectively. So here, let the normal to the plane from the origin intercepts the plane at N. Okay, so I'll show the diagram. So here X, Y, Z. So these are the three crystallographic axes and OB the origin. OB the origin and X, Y, Z are the crystallographic axis. And the plane is A, B, C. So somewhere it is intercepting A, B, C. So this ABC plane is intercepting on three crystallographic axes at the distance on OA is A by H, on Y axis it is at OB with the distance B by K, B by K, and then on Z axis OC at C it is intercepting. Okay, so the distance OC is C by L. So let OA, OB and OC be the intercepts made on orthogonal axis. So let the normal to the plane from the origin intercepts the plane at N. So this is the normal to the plane which is from the origin intercepts the plane at the distance N. At the distance N. Distance of the normal from the origin is the interplanar distance D. So ON gives the interplanar spacing, that is D. So distance of the normal from the origin is the interplanar distance small d. So let the angles made on the three crystallographic axes be alpha, beta and gamma. Then the interplanar space or interplanar distance d between the origin and the plane can be determined. So later we can determine the values. So let OA, OB, OC be the intercepts made on the orthogonal axis OX, OY, OZ. ON the perpendicular distance from the origin to the plane. So this is the ON which is perpendicular distance from the origin to the plane. Okay, so D is the interplanar distance. So here this is the interplanar distance. So origin to the plane. So the interplanar distance is small d, and alpha, beta, gamma be the angles between ON and OX, Y and Z respectively. So here the distance of interception from the origin on x-axis is OA is equal to A by H. OA is equals to A by H, this distance. So we are taking the plane ABC. So X, Y, Z are the crystallographic axis. And alpha, beta, gamma are the interspatial angles. So this X, Y, Z, that is alpha, beta, gamma are the angles between ON and X, ON and Y, ON and Z. Okay. So that the interceptions made on x-axis is OA. The intercepts on y-axis is OB, that is at B, and the interception on z-axis is C. So the distance from the origin to C is OC. So this OA is equals to, the distance is A by H, OB is equals to B by K, OC is equal to C by L. Okay, the intercepts made on X, Y, Z or at A, B, C, that is OA is equals to A by H, OB is equals to B by K, OC is equals to C by L. So now taking triangle ONA, taking triangle ONA, cos alpha is equal to ON by OA, that is equals to ON is at distance D, small d, interspatial distance, divided by OA. OA is A by H. So D by A by H, that is equals to D into H by A. Next, taking triangle ONP, cos beta is equals to ON by B by K. So as OB is equals to B by K, so ON is equals to D. So D by B by K is equals to D into K by B. Next, taking the triangle ONC. Triangle ONC, cos gamma is equal to ON by OC, that is equals to D by C by L, is equal to D into L by C. Okay, this is for the plane ABC, which is intercepts on the three crystallographic axes at A, B, C, which are at a distance OA is equals to A by H, OB is equals to B by K, OC is equals to C by L. Then we took the normal to the plane from the origin, that is ON. So ON being with the distance D from the origin. So then we have taken the triangles ONA. So from the ONA, ONB, ONC will get cos alpha, cos beta and cos gamma. From the law of direction cosines, Cos square alpha plus cos square beta plus cos square gamma is equal to 1. So what's the value of cos alpha? Cos alpha is equals to d into h by a. That is the value we got here. And cos beta is equal to d into k by b. And cos gamma is equal to d into L by C. So from the direction cosines law, cos square alpha plus cos square beta plus cos square gamma is equals to 1. So that when taking squares, cos square alpha is equals to, will get squares. So that the value will become d square h by a square means h square by a square plus d square k square by b square plus d square into L square by C square is equal to 1. So we can write for our simplicity d square by a square to h square plus d square by b square into k square plus d square by c square into L square is equal to 1. So for a cubic system, all three sides be equal. So A is equals to B is equals to C. So then this equation becomes d square by a square into h square plus k square plus L square is equal to 1. As all the sides being equal, so that we can take this as when a is equals to b is equals to c, then we can write d square by a square into h square. When a is equals to b is equals to c, then we can write d square by a square h square plus d square by b square k square plus d square by c square into L square is equal to 1. When taking this a is equals to b is equals to c, then it becomes d square by a square into h square plus d square by, as a is equals to b, we can write a square. K square plus d square by a square to L square is equal to 1. So can take common d square by a square. Now h square plus k square plus L square is equals to 1. This is for cubic system. So in cubic system, all three sides be equal, so that a is equals to b is equals to c. Then we can write this equation like d square by a square into h square plus k square plus L square is equals to 1. So now we can simplify this one. So d square is equals to a square by h square plus k square plus L square. So d square h square plus k square plus L square is equals to a square. Then d square is equals to a square by h square plus k square plus L square. Then what for d? So D is equals to A by root of h square plus L k square plus L square. So this is the interplanar spacing D, which is for the plane ABC, which is for the plane ABC. Now we are taking a parallel plane, another plane which is parallel to ABC, and intercepting the three axes at A1, B1 and C1. Then this A1, B1, C1 plane, the interceptions be the distance of 2a by h, 2b by k and 2c by L from the origin. So before we have taken y, z, x. So we have taken a plane here. So it simplifies. So it intercepts. This is the A, B, C plane. ABC plane. Now we are taking another plane which is parallel to this ABC plane. So the intercepts on the three crystallographic axes is A1, A1, B1 and C1. So then the parallel plane is so this is the parallel plane to the ABC on the crystallographic axis intercepting at A1, B1, C1. Now the distance from O to A1 is 2a by h. So the distance OA1 is equals to 2a by h, and the distance from the origin to B1 is 2b by k. As like the same, origin to C1 on z axis is 2c by L. And the distance, interplanar distance is 2d. Okay, so here we are considering a parallel plane intercepting the three axes at A1, B1 and C1. So let the distance be OA1 is equal to 2a by h, OB1 is equals to 2b by k, OC1 is equals to 2c by L, which is from the origin. So it makes the same angles alpha, beta and gamma with x, y and z axis. Then its plane or interplanar space from the origin O is n1. So that n1, O n1 is equals to 2d distance. And this 2d is equals to 2a by root of h square plus k square plus L square. As we got from the ABC plane, the interplanar spacing D is equals to a by root of h square plus k square plus L square. Like the same, here also, when we are taking 2D distance, that for the second plane, A1, B1 and C1, so 2D is equals to 2a by root of h square plus k square plus l square. So now we are going to say the interplanar distance, that is the distance between the two parallel planes D. So we are determining the distance between the two parallel planes. So the distance between ABC plane and then A1, B1, C1. So the distance between these two planes is D. Okay. So from ABC plane, we got the value interplanar spacing from the origin D is equals to A by root of h square plus k square plus l square. But from the second plane, parallel plane to the ABC, 2D is equals to 2A by root of h square plus k square plus l square. Then the distance between the two parallel planes will get by subtracting the d values, that is 2d minus d. Okay, so the interplanar distance between two planes is given by ON1 minus ON. So that is 2d minus d. When subtracting 2d minus d is equals to, the 2d value is 2a by root of h square plus k square plus l square minus the d value is a by root of h square plus k square plus l square. So that d will become as d is equals to a by root of h square plus k square plus l square. So this represents the interplanar spacing between the two parallel planes. Okay, so in this diagram here, OB the origin and X, Y, Z are the three crystallographic axes, and we have taken the first, we have taken the plane OBC, OBC plane. So this OBC plane is intercepting the three axes at A, B and C. So the lattice parameters OA is equal to A by H, OB is equals to B by K, OC is equals to C by L. So the distance between horizon to OA, horizon to OB and horizon to OC, that is intercepting distance from the origin. And the angles made with OL. So that's why we are taking a normal to the plane. We are taking normal to the plane from the origin is intercepting at N. So the normal is intercepting the plane. The normal is intercepting the plane at N from the origin O. So the distance between O to N is D. Distance from O to N is D. Okay. So then we have calculated cos alpha by taking the angles. Angles we have taken. So the angle made with N. So normal. So that this is alpha and this is beta and this is gamma. So these are the interspatial angles. So cos alpha calculated, cos alpha, cos beta and cos gamma. So these values become D into A by H that is D into H by A. So cos alpha is equals to D by A by H. Cos beta is equals to D by B by K. Cos gamma is equals to D by C by L. So then we took directions of cosines, so that D square by A square into H square plus K square plus L square is equals to 1. So when A is equals to B is equals to C. For a cubic system, we got this value. So from this, G is equals to A by root of H square plus K square plus L square. So this is the D for ABC plane. Now we are taking another plane. So the another plane is intercepting at A1 on x-axis, B1 at y-axis, C1 at on the z-axis. So the distance from the origin to N1 is 2D. So OA1 is equals to 2A by H. OB1 is equals to 2B by K. OC is equals to 2C by L. Now ON1 is equals to 2D. Then for the same, cos alpha is equals to here 2D. So that 2D by 2A by H. Cos beta is equals to 2D by 2B by H. Cos gamma is equals to 2D by 2C by L. Sorry, this is K. Okay. Now, taking directions of cosines law, we'll get the value 2D is equals to 2A by root of H square plus K square plus L square. So what is the distance between these two planes? So we'll get 2D minus D from 2D minus D. So that we'll get A by 2A by root of H square plus K square plus L square minus A by root of H square plus K square plus L square. So that D is equals to A by root of H square plus K square plus L square. So this is the interplanar distance between the planes A, B, C and the plane A1, B1, C1. Okay, so D is equals to A by root of H square plus K square plus L square. It represents interplanar spacing between two parallel planes. Between two parallel planes. So next we'll talk about lattice constant. Lattice constant. We'll derive the expression for the lattice constant. So for that we are considering a cubic unit cell. Cubic unit cell with lattice parameters A is equals to B is equals to C and the interspatial angles alpha, beta, gamma is equals to 90 degrees. Okay, alpha is equal to beta is equal to gamma is equal to 90 degrees. Then let rho be the density of the cell. rho be the density of the cubic unit cell. Since the edges of the cube are equal and constant, it is known as lattice constant. So that is A is equals to B is equals to C, that is equals to constant A, lattice constant. So as the edges of the cubes are equal and constant, it is known as lattice constant. A is equals to B is equals to C, that is equals to lattice constant A. So now we are deriving expression for this lattice constant A. For that, we are taking volume of the cubic unit cell. Volume of the cubic unit cell. So, volume of the cubic unit cell is A cube, and mass of the cubic unit cell is volume into density. So, A cube into rho. A cube into rho. Now, let M, capital M, be the molecular weight of the cell. M be the molecular weight of the cubic unit cell, and Na be the Avogadro's number. Na be the Avogadro's number. So mass of the each atom in unit cell, mass of each atom in unit cell is equals to M by Na. So if there are n number of atoms in a unit cell, then mass of the unit cell is equals to Nm by Ne. So N is the number of atoms, M be the molecular weight of the unit cell, and Na is the Avogadro's number. So mass of the cubic unit cell is equal to Nm by Na. So let the mass of cubic unit cell be the equation 1, and mass of the cubic unit cell in this case is equation 2. So from 1 and 2, let equating both the expressions, A cube mass of the cubic unit cell in the sense of density, A cube rho. So A cube rho is equals to Nm by Na. So as you know that volume of unit cell A cube, rho is the density of the cell, and then N is the number of atoms in that unit cell, M be the molecular weight, Na is the Avogadro's number. Okay, so from this we are going to derive A, so that A cube is equals to N M by N A into rho. Okay, so from this A is equals to, so cube A cube, this is for A cube. Now A is equals to Nm by rho Na whole power 1 by 3. So N whole power 1 by 3. So this is the expression for the lattice constants. So this expression represents the lattice constant. Lattice constant. So in this lattice constant, we are taking a cubic unit cell, and the lattice parameters for the unit cubic cell is equal, all sides being equal. So A is equals to B is equals to C, and interspatial angles also be the same for the cubic unit cell. So that is here from the picture, here are three crystallographic axes X, Y and Z, and the interceptions on the three crystallographic axes is A, B and C. As we are taking cubic unit cell, this all the distance of OA, OB, OC, OA, OB, OC are same. So if we take OA, the distance is A, here the distance is B, here the distance is C, so that A is equals to B is equals to C. So the distance be the same. So that's why here the edges of the cube are equal and constant, so we call it as a lattice constant. So we are going to derive that lattice constant A. Okay, so for that first we have taken volume and then density, so that mass of the cubic unit cell is A cube into rho. So taking as first equation, then we'll go for another. So mass of each atom is capital M. So M represents for molecular weight of the cell, and then Na is the Avogadro's number. So M by Na. Then we are taking N is the number of atoms in that unit cell. Then mass of the cubic unit cell is equals to Nm by Na. So next we are taking, that is equating 1 and 2 expressions. Then A cube rho is equals to Nm by Na. So from this we need to derive A, so that A cube is equals to Nm by rho Na. Then A is equals to Nm by rho Na whole power 1 by 3. So this expression represents the lattice constant. Lattice constant. So this is all about the lattice constant and the interplanar spacing between two parallel planes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.